Okay, so we were talking about creating an object from an existing object, right? The last topic that we were discussing about was creating an object from an existing object, or in other words, while we create a new object X, I would like to initialize it after creation with respect to some previously existing object Y. So what is the protocol? What is the rule for that? What is the syntax for that? And what sort of issues are there related to that we are discussing? Okay, so here just focus on this. I think it is the fonts are visible. So in the line 42, we have got one object M, and then we are calling m.display. So the same code that we are that I have shown during my last class, I'm talking about that. And the line number 44, we are trying to create another object N, getting it copied from M. So it is initialized after creation with respect to M. And then we call fn and display using that object N, and something is done. And as this N is within the scope of this for lines 43 to 47, so once a control comes out of it, the object N gets destroyed, and this will indeed be destroyed, and does not matter how or using which constructor it has been uh, constructed. If you have got a destructor, it is not the default destructor, and in fact we are having that in the line number 32 to 36. There is a destructor, and we know that destructors cannot be overloaded, so that destructor, whatever it is there, will be definitely invoked, does not matter how you have constructed the object, right? So in this case, when n was created and it goes out of the scope in line number 47, so a destructor corresponding to n will get invoked, and you will get the prompt destructor. After that, this m, which still remains in line number 48, it calls display, and something will come out. And then I'm just trying to create another object P from M, from the state of M. So again, I'm trying to initialize P with respect to M. Okay, so the syntax here, if you write xyz P equals M, or this, so both are same. Can you follow this? So both of these are same. So is that okay?
Yes, sir.
And so this also you could have written like this, does not matter. So the thing is, what we found during discussion, that so definitely there are three objects created, M, N, and P. And because we have got a destructor, so destructors will be called, the destructor function or method will be called thrice. But when we talk about constructor, the only constructor that we have got is of, so right now just comment on this. So the only constructor that we have got is this one, right? Which is having a constructor initializer list in terms of this. So this will prompt constructor. This string will appear if it is invoked, and hopefully when we call M with 10, so this copy will be invoked, right? But we don't have written, at least now, any constructor of how to create an object from another object. So in this case, it will invoke here default constructor, default, to be specific, default copy constructor. Okay, so in this case also it will invoke default copy constructor. Okay, so default copy constructor means there is no comments and all this. So the construction will be this ordinal constructor, the user defined constructor will be called once, but the destructor will be called thrice. So if we run this code as we are discussing, what is the name of this? Oh, this is, I have to comment this also. Okay, so one destructor, one constructor, and two normal functions. Okay, so if I run this, so this is what we found in those slides also. One constructor is called, and but the destructor is anyway called, no matter how you construct. So this part is clear.
Yes, sir.
So now let us come to the point. So, but something that we are not happy with is this one, right? Is the value of 0. So what it corresponds? It corresponds to this one. It corresponds to this one. M dot display. So M, what value you have assigned? 10. And is there any change that you made in the N? No, because you just displayed it here, and after the this inner scope, you have again displayed the M. So before and after, it has got different values, right? So initially it displayed the value 10, but then after that it displayed the value 0. In between, another object got created through the initialization process, and it got destroyed, and that created some sort of uh, uh, like situation which we do not want, because as a side effect it altered the value of the object from which it has got copied. So we would expect, instead of 0 here, what do you expect? What value you expect? Here also
10.
what do you expect?
10.
The value 10 without any change, right? So it is like I gave you my handwritten notes, and I asked you to create a copy of your own, get it xeroxed and return it to me, right? And then in your original copy you can do anything in your xerox copy, but while you returning me, if I find that that got also tampered, I will not be happy. So in fact, it's like I gave you the notes, but you said that, okay, why should I copy all the get a xerox of all these pages? It will be costly for me. So I'll just whenever I require, I'll use his notes only, and I'll update on his notes only. That's a problem, and that is the problem that has happened here. We'll see in details. Okay, so although you are expecting it to have a clone, a separate copy, and then there you modify, but it is not happening. So that's why this problem occurs. So how do we do this? Okay, let me now. Sorry. So what happens? So that's why we say that we are calling the default constructor here, and this is the case. So let us look into one by one the problem. So when we are in this particular line number 35, what happens? M. So which segment M is taking the space from this object M? Which segment? M is a local variable. So which segment it is getting space from?
Stack.
Stack. What is its size? How much size it? So what are the members? How many members it has got? Now a bit quickly try to answer. It's unnecessarily too much of time is getting wasted. So how much time?
One integer
One integer,
pointer.
one integer and one integer pointer, right? Because one is a reference, so that is,
Yes,
so it
sir.
is like A or say B and for P. Right? So this is for the P and this is for A or B. Okay, so initially what value will be there? M. So in that A, as we see here, you see once it is allocated, so we are initializing with value 10. So value 10 means B gets the value 10. So B means it is A or B, whatever. So what value will be stored here? Here it will be 10. Okay. And what else? Now here we have in this particular line, right? In the line number 21, what is there in line number 21? You have allocated, you have asked for a separate allocation from the heap. Okay. So if this is a heap segment, so how much space it requires for one for integer value, and then p points to this particular one, right? So what I am talking about, so this is basically m. So this is actually the object m. Okay. And what we are storing here in this location, asterisk p, what we are storing, the value of x. What is the value of x?
10.
This is 10. It will be storing 10. Is that fine?
Yes, sir.
So if it's storage, the base address is 2020, it will be 2020. Now m dot display, so m dot display is just displaying the asterisk p, so it will be displaying 10. So this constructor is invoked, and this is fine. So now we come to this line number 37. What it asks, to create another object n from m. So another object n means which segment it will be getting the space for n?
Stack.
Again from the stack, right? Because it's also local static. So this is say n, but it is using default copy constructor. So when it is using default copy constructor, so the rule that it follows is like this. Say it will copy, so it will also have two things: a space for its own p and its space for own a or b. Now what it will do, if you use default copy constructor, it is not intelligent enough, and you will simply say that, okay, let this 2020 be copied here, so this will be copied here, and this will be copied here. Okay, so 10 will be copied here. Is that part fine?
Yes, sir.
So can you all see what is there? So it is like, so the entire thing is copied, just all the bits. So it is basically bitwise, whatever you are having here in the object m is just blindly copied in the object m. Okay, so this is just bitwise, you copy the contents of m to n without bothering about what will be the issue, or whatever problems you have or not. You really don't care about it. So once it is done, now you see what happens. So here, after that, we are now n was constructed. Now n is fine. This is n is there. Now I write n dot fn. N dot fn means you are trying to get into the location pointed by p. That is actually 2020 is also pointing to. So if I use this particular color, so this also points to the same location, right? So both are pointing to the same. Now you are telling that asterisk p should be z. What is z? Z is 25. So it stores here. It just overwrites here with 25. Is that fine? So the problem is m wanted to help while n got created, but in doing so, in a in a not in a normal way. So both is now pointing to the same location in the heap. And then if you write n dot display, what will you display? So n says asterisk p, n dot display means asterisk p, it will be displaying 25. So this is also fine. And automatically when the control comes out of it, there is a destructor and it will be invoked. And what it will destroy? It will destroy n, the object n. So that's why this destructor is invoked, because it shows that the destructor is invoked, right? But what do you think? What does this destruction of the object n means? which of the space will be deallocated?
Heap.
You see here it was delete p, delete this parenthesis p. That means whatever this p of whom, p of means this is, if you use this pointer, if you consider, so this is the object ends p. Object ends p is this. So you are trying to free deallocate the space here. So this entire space will be deallocated. Okay. So it will be deallocated. And then after that, what will happen? So that will be the first step. So what is the second step? Second step is the whole thing will be removed from the stack, right? That is what deallocation of n means, as you wrote this logic. Is that fine? Is that okay? In line number 41, and I mean before line number 41. So what does it contain now?
Garbage.
Why garbage? I mean, maybe it was now it is stored the same value 25, but to us it is garbage because this storage or this few bytes is no longer for your use, for the use of this code, because the memory management module of the operating system will treat that to be a garbage. So it can have any value. It can have the same 25, it can have 0, it can have something negative value. We do not really know. Okay. So now after that, even just after exiting, when you are trying to display the value of m dot display, then what happens? When I execute this line number 41, m dot display. So m means m. So this object m dot display, that means I would like to get the value of asterisk p. So asterisk p means this one. So what you are expected, what you are getting or displaying where? Is that fine? Is that okay?
Yes, sir.
So this is basically accessing garbage. It could have 25 also. We really do not know. But in our case, it is giving 10 0. So the thing is that particular location which was in your control and it was actually allocated, now is not allocated. Maybe after few say at some later point of time, if you call new, the same would have been allocated to some other say new call, and you may have obtained some different values. Okay, so suddenly you find that the aim is behaving mischievously. I mean, it's giving different values at different times, and you really do not know what is happening. But this is the case. And then if you write here xyz pm, so what is going to happen then? Again another p. So where it will get the space from? It will be again from the stack segment, because this is also a local variable. Now p is again getting copied from m. So this is what means. So this will be 2020, and this will be what value it will have here? In that variable a, member a of p. Hello?
10.
If I execute this, what will happen? Hello?
Sir, a new class created.
No, I mean this p, I am creating a new object p from m. So what will be this value here? Can you see this? I'm asking about this value.
Okay.
What it will do? It will be basically same. It will be copying bitwise.
10.
So it will
Yes,
be
sir.
again 10 here, right?
Yes, sir.
We are not doing anything, but anyway, it will be 10. Now, when you exit from this, when you exit from the code, because that was the last line, when you exit from it, then what will happen? Both p and m need to be destroyed, right? Because those are the only
Yes, sir.
things that, so both will be destroyed, and they will be destroyed by invoking this destructor function, destructor method. And because it is using destructor method, so this and this will be displayed. and it will be in the, so this destructor is meant for destroying the P, and this is meant for destroying M. The first one was just for destroying N. Is that fine? And this constructor is for constructing M. Is that okay?
Yes, sir.
So in fact, the thing that has happened at line number 42 is that both P, which was already pointing after the destruction of N, P was pointing to garbage. I mean, the member P of M was pointing to garbage, and you have copied, sorry, the member P for this object M was pointing to garbage. Now the object P's member P also is pointing to garbage, right? So this also actually, this points to, this also points to garbage. So both are pointing to garbage. So I think this problem was, you found the problem. So what is the solution now? What is the solution? So just I'm not coding, I'm talking about the code. So how to take care of this problem?
So to make an actual copy of M and N so that it will not point the same location.
So the thing is, simple thing is, you should first of all bypass this default constructor, right? So this, so don't take anything that is offered in free. Okay, so you have to avoid using this default default what constructor?
Copy constructor.
Copy constructor. So you have to, so what you have to actually need to do, write okay, write your own copy constructor. Is that fine?
Yes.
So do not use this default copy. So if you write your own copy constructor, automatically the compiler will not offer you the default one. So you have to write it explicitly. So how to write it? So first thing is just focus on this. So now when you are asked to write it, so this is main, and we are facing a problem something like this. I have got XYZ M, and I'm trying to create another XYZ N out of M. So from this syntax, can you tell me what it is passing here? So I have to write a my own copy constructor. So what will be the name of the constructor first of all in that class XYZ? I'm just ignoring the rest of it. So I'm trying to write a copy constructor. So what should be the name of the copy constructor? What is the name of the method?
XYZ.
Because it is anyway, it is a constructor, right? Constructor. So any constructor will always have the same name, that of the class. Okay. So this is same, this is the same, like this. Now, how many arguments it will accept? Will it accept any argument?
So for copy constructor, it will accept.
So will it accept any argument? Can you see here?
Yes. Yes, sir.
Yes, sir.
So how many arguments it will accept?
One
Argument. And what is that
XYZ.
argument? So what it accepts? It accepts
object.
It accepts some object. So one from which you want to copy, but in what form it will accept the object? Will it be so definitely if I am allowing this kind of syntax, what I am passing here? So passing the object M's, can it be address? Am I passing the address of M?
No, sir. Value.
Cannot be. So there are two options left. One is the value, or you pass the reference, right? Okay. So if I write here, so I am passing an object of XYZ, and if I would like to hold it, say in A, which is a temporary object of XYZ. Okay. So will it work? What do you think?
No, sir.
No, sir. You have to pass the reference because you're
No,
copying the
why
values
it
from
is
M.
not? No, why it will not work? So I am passing the object, and I'm passing, if I am passing the value of the object, so the value of M is passed to X, to A, then what is the problem? This is fine. What will be the problem of yours?
So the same
Definitely I'm
thing
not
will
passing the
happen.
address, but yes.
The same thing will happen like in the default copy constructor.
Yes, now the same problem, because what you wanted is to create N from M, right? And because you faced the problem, you thought of writing your own copy constructor. Okay, and we know that constructor cannot return anything, so there is no point of writing something here. But if you are trying to pass the value, that means what? Again the same thing. The M, you would like to create a local copy of A, another object A, which is getting copied from M. So to solve a problem, you still dig out the same problem once again, right? Are you getting the point?
Yes, sir.
So if I force it, what will be the output? If I run run a copy constructor with this kind of parameter, then what do you expect there?
So the output of the previous one. If the same program is run, then the output we get on the previous one, it will be same like that.
My question is very simple. If I, first of all, if I do this, if I write this, will it be compiled successfully? If the answer is yes, then what will be the output? If it is not compiled, then it is fine. So what will be the answer? Are you getting my question? Specific question?
It will be not compiled.
It will not be compiled. Let us see this. So my question is, again, let's not focus on what is the internals of copy constructor. We'll write it shortly. So just ignore these lines. Those who are not familiar with C++, just ignore those lines and ignore all these also. Let's make it simple like this. So now are you happy with this? Line number 24, what we're discussing. I'm trying to create N as if I am receiving the value of the one through this I'm copying, right? So this is what I mean. So the value of M is copied to N. So this is call by value, example of call by value. This is example of call by value. Okay. So let's see if it is compiled or not, allowed to compile or not. Okay, so there is another mistake here. What is that? This need to be also changed accordingly. I've commented it. So I say that let it be this. Is that okay? Hello?
Yes.
So let's see if it is compiled. What it says? Line number 12. So line number 12. Yes. So XYZ, and this is, so what is the comment? Can you see?
So XYZ index, then I can be it is showing.
So if we try, so it is not getting compiled. So if we try something like this, so you say that okay, call by value is not possible. So let us pass call by reference. So here also and here also. So here also I give reference. This might be possible.
Yes, sir.
This is allowed, right? Everybody accepts it. So now we found that like intuitively also we can explain that to overcome the problem or the side effect of creating an object from an existing object and ending up with values, garbage values at some point of time, because if you just keep on doing that, so multiple objects will be pointing to the same location in the heap, and if one gets destroyed, it will affect the existence of the remaining ones, right? So we should not pass. So we have to write our own copy constructor, and if we do so, if we pass it by value, the same problem recurs because you are again having the same, and that is not allowed. So if I pass the reference of it, then what happens? This is compiled. So this is successfully compiled. And if we pass it, you see, can you see the difference now? Earlier, how many constructors were invoked and
Yes,
how many times the constructor keyword appear?
one.
One. Now it appeared 3 times, but now one is the normal constructor, but the other two is the my own copy constructor that I wrote, right?
Yes, sir.
And you can you find the change here, the value of that m after the end of that inner loop, inner scope? Earlier it was 0.
Yes, sir.
Now it is
Zero.
10. That is the original value that you want, right? So this
10.
works perfectly. So this works perfectly. So is it fine? So what do we do here actually? So what should be the internals of this copy constructor? I mean, coming to it later on, later a bit. So the first thing is, okay. So this call by address is not possible, call by value is not possible, so call by reference is possible. So I make it like this. So it will work, right? So what I would need to do here, so here what I need to do is I had the stack segment and I have the heap segment. I had the object m, objects m, p and say a. So this is the object m. Okay, so this is m, and now I would like to create another object n. So this is a construction process which I say. So what I do here is a, okay, so it's all becoming confusing because of the names, similar names. So here let it be called as say b. Okay, so this is say b. So it's a reference to the same m. So which one is b? So will b get another allocation?
No, sir.
Hello?
No, sir. No, sir.
This was m and this was again b, right? And I'm trying to use
Yes,
this
sir.
new reference within this construction process, right? So what I need to do is to create space. So anyway, so this whenever you are asking this constructor, so the space for a new object that is what you require will be given to you. That will be allocated. So this is what this is for this n. So this is for the n. It has got its own space for its private for its public member p and a, right? That the only change is you don't want these things to be copied blindly, right, bitwise. Rather, what you would like to do, so this we do not want, and maybe that this is the location which was pointed by this original object m or b, so which was say 2020. So what we want is you can give a comment cout copy constructor, and then what should I do? Instead of both allowing the both to share the same say location in the heap, I should allocate a separate space for this new object, right? So what I should do now? I should call new int and assign it to p. Whose p it is? Assign it to p. So whose p I am talking about?
N.
The one that I am going to construct, right? Think of the this. The one that I am getting, that is getting constructed. The object that is getting constructed, right? So this is that P. So what P? So I'm talking about this P. Okay. So here, so whatever, so whenever I write this one, so I'm asking for some additional space allocation. This is the say the space allocation integer for an integer, and I'm assigning it to P. Whose P? N's P. So if this is say 1080, so this will be done, and it will be pointing to this one. Okay. What will be the contents here? If it was 10, what will be the contents here?
10.
So how do I specify it? So it should be initialized. What should be the initial value? Because you would like to have this n
B
as a
dot.
clone of this n. So it should be this value, right? How to access this value?
B dot P.
B dot
P.
B dot P. Why B dot P? I would like to have access to these contents.
P
Hmm?
star. B dot
What
star.
should I write? What should I write?
B dot asterisk P.
B dot B dot P asterisk, right? Can I write this? B dot P means this one. Asterisk means you will get this value. Can I write this? Hello? Hello?
Yes.
Yes, sir.
Yes, sir.
B dot P is this. Asterisk means you are getting this 10. So I am initializing with that. Then what else I need to do? So this gets copied the value 10. Still it is not done. So this part is also done. So it has got a separate space whose base address is stored here. And what about this A? This new objects. So earlier it was automatically copied bitwise, but it is you have to do it explicitly right now. So ends A. How do I specify the new objects? A means it is just A, or I can write as in fact B is also confusing because B has also got a the same name. So let us better write it as something else. So this is say C. Okay, so C dot X, C dot P. So what is the value? How to get the value of A here? What it will be this? What it will be? It will be M and C, but you cannot use the name say M. So it will be C dot A. Is that fine? That means whatever is stored here,
This dot A is equal to
so it will be copied here. Okay, so you are explicitly copying it. Is that what fine?
Yes.
All others can you follow? So now it is really a clone. Now this you see M or C, whatever you say, this particular object. So this particular object, it has got its local it has got some location in the heap pointed by P, but this new object N, which was copied from this one, it will also have its independent space to which its P points to, but because it is initialized, so that's why both are having the same state. Can you see the state of N and the state of M? Both are same in terms of this, but they are independent. So if you do something like this, okay, so if you put this within a parenthesis within a local scope, then what happens? If the control comes out of it, then the destructor gets called, and destructor what it does? Destructor what it does? It calls delete that parenthesis P. So this will be deleted, right? And then it will go on in addition to that deleting this part also. So the whole thing gets destroyed once it comes out. But that does it affect the original M now? Hello? Can you follow this? Hello?
Yes, sir.
So got the effect. So if I write a copy constructor, my own copy constructor to be specific, then even if I have copied n from M and the control comes out and the destructor is called, so that is not going to affect the original object from which it has been copied. It remains intact in its own space. So nothing will happen. And that is why if we include a copy constructor and then we try to do this, the content of M or the content of the location pointed by M, the pointer member P does not get affected. So instead of relying on default copy constructor, you have to write our own copy constructors. But sometimes, but in many cases, you may not need to write it, right? In what cases it is mandatory to write our own copy constructors? Yeah. When do you need to include your own copy constructor? When it is mandatory to have your own copy constructor. Are you getting my question?
Yes, sir.
When?
When we have
So
pointers as data members.
When? Yes, one at a time.
When we have pointers as our data members.
Yes, because if you have a pointer data member, you really do not know what is going to happen. So whether you have allocated space or not, you don't know. So it is always safe. It is not only safe, but it is recommended and it is mandatory that you have a copy constructor written for any class which is having a pointer member. Is that part clear? And that is compulsory to avoid any sorts of any kind of hassles or any kind of anomalies later on. Do you accept the statement?
Sir, yes, sir. Sir, I mean, if it is there is pointers, I mean, every type of pointer, or when we are using dynamic allocation only then.
See, that is what I mean. So you can always examine and find out that okay, whether any such things are there, but it is always recommended that if you have a pointer member, you should do it, because pointer member, why do we do? If you have a pointer member, you don't go for dynamic allocation. So do you require
Okay.
that? So you may not require that, but it's better to have a good practice that you have a pointer. So just do it. It's like in the stack class. In the stack class, do you think that you need a copy constructor to be included?
No.
The stack class that we
Yes,
discussed, we must have, right? Because otherwise you blow you blow out that whenever another stack is getting copied, if the that particular stack object gets destroyed, so it affects the previous one. So the stack space is completely gone off. So this is a problem. So again, you can always look into the details of it and all this, but a good practice is have a pointer member, just ignore anything and just write a copy constructor, even though it is not asked, because otherwise you will be in trouble. And at some point of time, ending up writing a 1,000 lines code, you find that something went wrong, but simply because of this, simply because you are trying to create an object from another object, and when it is required, sometimes when you are passing an object to some other function, by through call by value, you will face the same problem. So simple trying to pass an object to another function, local object, passing by value, will you will end up with such problems. So we can summarize our observation that whenever a class is having a pointer member it is compulsory to have uh, to write our own copy constructor. Don't rely on the default copy constructor. Do all of you accept that?
Yes, sir.
And this is what we found also. So the issue here also got rectified. Once you have that, you have everything perfect and consistent. Now let us see something like this. You are doing this, and then okay, there is another issue. Can you see this? That P was a private member. I think sometime back, I mean, in the last class, somebody of you asked that whether using this pointer you can access the private members. Somebody of you asked, right? Who was he?
Yes, sir.
Yes.
So
Can you
me.
see this? So P is a private member, and I'm accessing it using this P, and still this works. There is no error message or
Yes, sir.
anything like. So this is because you are accessing the objects members. Some of them may be private or public, doesn't matter, and you are accessing it
And
within your scope, within the class's scope, so it will not create any problem. So writing it explicitly at this P or just writing as P, so this is all the same. So writing this as phis arrow P is more it's redundant, right? Or you can say that the compiler will do it in any way. I mean, even if you don't do this, the compiler will, while compiling, it will decorate these lines like this. Okay, because it will also insert some this pointer in each method that we already explained. Okay, so and using this you can access private member. So that part I think you can check it.
Sir,
Now the point, yes,
sir, try to initialize A here in that public part.
try to
Uh,
initialize A
yes, sir.
in the private part.
In the public means in that part you told no that we can't initialize the data members.
Which part I'm not getting? So which line number you are talking about?
In line number 9 we can't
Yes.
initialize the variables you said,
Okay,
no sir.
okay, yeah, yeah, I got your point. So let us try this.
We can initialize.
This one. This one you say, na?
Yes.
Let's see. This gets okay. This is shown anyway. So if I write a const keyword, const index, okay, yeah, it is working. Yeah, but I have not done it anywhere. So yes, so this accepts.
Yes, sir.
Maybe this, although it is a template, so the thing is, although it is a template, so it acts as a executable only when you are trying to create that object. Okay, but I think the best way to do this is to use the constructor initializer list and write it here. And that is the best, the good practice. But anyway, the compiler uh, allows it. That's fine. Yeah, I have not done it. I have not checked it yet earlier. That's a good point to note. So Yes, so both are allowed, but I would prefer to have it like this. Yeah, thank you for pointing out. So let it be x, y, or 10. What is the problem? Okay, so this needs to be here also. So that is the point. So wherever you have to write a constructor, you have to use the same constructor initializer list in both the
Yes, sir.
cases.
This is one of the problem I see that
Yes, yeah, I got
using
your point. So why should I repeat
backlist.
it every time?
Yes,
I
sir.
could have done it in this position itself. Yes. Okay, that I accept. Yeah, that I have not tried earlier. So now, is there any other point that we have got? So here you see this is n dot a, n dot a. So uh, n dot a. What is a? So actually, because they are the same, I have copied it, but it should be not n dot a. It should be that n dot p asterisk to be specific. In fact, what I did here is yeah. So this is more general, because this p may not have just one integer location pointing to it. It may have a array of pointers, right? So I am copying the value of n dot a. So I am allocating those number of locations, and then I am copying one by one them. Are you getting the point? It's just like the stack problem. So instead of just having one integer, a space for one integer, we have got a array of integers. Have you got this? The change? So this code I'll share. Is that fine? So I'm not initializing here. What I'm trying to do is, because it may have more than one integers, then I'm allocating a size of array of same as that of n dot a. And then I am copying the contents of that, like n dot a, I mean, one by one the values in this asterisk p. It is, what should be the value here? It should be p0. P0 copied to what should be copied to p0? What should be copied to p0? N dot,
Sir,
n dot,
P0 or PI?
sorry, pi. Yes, pi. It should be n dot pi, isn't it? Now it is fine.
Yes.
Right. So that is more general. Even if it is having just one integer, so that also will work. For multiple integers, that also will work. Now the point that I would like to highlight is n. So if I write n dot a plus plus, what does it mean? N dot a plus plus? The local copy of n, which is basically a reference of that original object, right? Hello.
Yes, sir.
So if I try, so you see, you have created a reference of that original object, where from you want to get a copy, a carbon copy. But if you would like to write n dot a plus plus, that means you are not only constructing your new object from the previous one, but you are trying to modify the state of the original object also. Here, will it be allowed? Maybe by mistake you are trying to do so,
Yes, sir. It is.
right? So if you are trying to do so, that also will be allowed. So maybe by mistake you have done that. So how to stop this to happen? How to make sure that this will not happen? You can just copy, but you cannot make any change of the state of the original object. whose reference you are working with. How to stop it?
Sir,
Const.
constant and
You just treat it as constant, right? So treat it as constant, because your intention is just to create a copy of it, not to tamper it, right? I ask you to I gave you my handwritten notes just to get a copy of that so that you can use it of your own, but don't try to tamper or write something on that, or modify something on that. Don't write dates or whatever, your name. That I do not expect. And how to stop that? So if I do this, hopefully it will be stopped. Let's see. Now you see it's quite obvious, because you say that now the local reference of the original object was treating its its reference to be a constant. It will ensure the constantness whenever you attempt to do so. Is that fine?
Sir, but is it mandatory to write const before that?
Yes, actually this is the signature of any copy constructor. This is the signature. You write it here or you write it here, it does not really matter. Write it here also, it should work.
So I'm saying like without const also it will be working.
It is already worked. I think without const also it just now worked. But can you see the side effect of it? If I, at any point of time, if I would like to, if there is an attempt to do something like this, even my mistake, can you stop this? Can you stop this?
No,
Hmm?
no, sir.
So try to use the const keyword, not just to declare the value of pi as 3.14. Try to use constant, the keyword constant given by the C++ compiler, in a more effective and useful way. That's where the const keyword comes. And this is a true signature. Signature means the prototype of a copy constructor. Is that part okay? So is this fine? Hello? Am I still connected?
Yes, sir.
Yeah. So you have to write a const keyword here, and a const keyword there only. So that way it works. And if I, so this is the actual code. The const keyword is here. You are trying to write it as a copy constructor. And now you see that this is the, so I think it should be the copy constructor. This has been copied wrongly. So this should be copy constructor. Okay, so this is done. Now if we so these are some of the points that we just now discussed. So default choice in object to object copy is shallow copying. We say it is basically shallow copying. Why shallow copying? It just copied bitwise. Bitwise copying is often called as shallow copying, and solution is deep copying. That is basically writing an explicit copy constructor. So this is default copy constructor, the same problem. Original object and the cloned object both points to the same reference in the heap. But if we have a deep clone, or if we have a explicit copy constructor, so both will have their own independent copies. Okay. Fine. So this is just to show you the case of the stack class with copy constructor. Essential, as it has got a pointer member here. So where is the copy constructor shown here in line number 21? You see, so the signature is this. So x So the signature of any copy constructor is mentioned as this. Sometimes it is this, but it also sometimes it is shown as this X. This also will work, but this may be harmful, so it's better to use this. Okay, so the details of the stack copy constructor is here. So in your same stack class, if you add this portion, see, because it's constructed not returning anything, and this is what it does. So it copies and so it allocates equal to the size of the original stack, the space, and then it copies one by one the contents from the previous stack to the new stack and all this. So that's the end of this class. So any question? So these are very trivial things, but these are important to note because so this involves the concept of reference, the concept of pointers, the concept of when and where constructors get invoked, and when the compiler gives you the default constructor, when it is got, when you need to write your own constructor. And default copy constructor is different from default constructor, so as you can see, and all the details of constructors and destructors we have explained. I've tried to keep the enough details, and there is a constructor initializer list also. As I too have found that okay, you can bypass it but just by initializing it there, but that will only work when you are creating an instance. Otherwise it will be just as a template. So but the syntax is allowed, that is for sure. And then but it's a good practice, and I think in many of the standard codes it is written in the constructor initializer list. Okay, so if there are no more questions, you can switch to the lab. It will be up to say 5 p.m. I know that the assignments are given today only, but if somebody of you can show some of the assignments, that will be evaluated or that will be noticed by the TS. And regarding tomorrow